All right, I'm now going to get into rapid shutdown systems.
Yeah.
And let me see what's going on here. Oh, there's no changes. Oh, it's a bunch.
Yeah, there's no change. It's all new. New.
There's no changes because
It's all
A
new.
is new,
Disney.
B is new,
Yeah, you got ends next to everything.
and
It's all new. It's
C
all
is
new.
new.
Just say new.
It's all new. So, all right, Bill, I'm going to go ahead and this is your PowerPoint.
Right.
So I will just advance it, and you
Sure.
tell me when to advance it, and you
Go
tell me
for
what's
it.
going on here.
All right, this is just talking about all the changes that were made in the code. Rapid shutdown used to be 133 words. Now it's 1,000 words, 1,100. So we have,
Rapid shot went from 133 to 1100.
so we tried to reduce words, and we didn't do that in rapid shutdown.
Okay.
So this is basically just the language here with the first exception we'll talk about. And again, this has to do with structures that are enclosing equipment that look like buildings that many jurisdictions have tried to call them buildings, and therefore we want to be super clear right up front. It has nothing to do with those structures.
I'm going to get that right there.
Yeah.
You're saying right off the get-go, exception. Let's start this off right, okay?
Right.
If the building, ground-mounted that are entering buildings in which the sole purpose is to house PV equipment shall not be required to comply with 690.12, which is what we are talking about. All right, so now we can move on.
This is a legitimate use of the word exception. Okay. Rather than the National Exception Code. Next slide. Oh, sorry. That's artist's rendition of what a fire on a roof looks like. You can go to the next slide. So here's several significant changes from the 2014 code. Obviously, greatly increased the detail.
Hey, 1 second, Bill. Tell us what we're even talking about.
Okay, let's
Big
back
picture.
the truck up.
Wait, what's going on? Why are we even? What
are we here?
talking about? What are we talking about? What's the concept? What's the history? What's happening? And then tell us what the code's telling us.
Absolutely. So rapid shutdown is all about emergency responder safety. That's the only real reason for its use and it being in the code. There may be other benefits, side benefits from it, but that's the focus. It has to do with the fact that a PV array is generally energized whenever there's light out. And that's any kind of light, pretty much. Difficult to get shocked on moonlight, but it's possible. Maybe at 1,000-volt systems, you might get shocked on moonlight. And so these systems, we've inherently said, well, we can't do anything for you on that one. Sorry, guys. We're just energized all the time. Get over it.
The way it works.
That's the way it works. Get over it. That worked for about 30 years. And long about 15 years ago, people started asking a lot of questions about that and saying, really, you can't do anything about that? And you can't do anything about it. And so then we started getting fire departments going, you know what, we don't care. We're going to require you to put a disconnect up on the roof. We're going to put a disconnect on the roof. We need disconnects. We like disconnects. You're like, well, wait a minute. They don't do anything for you. You put a disconnect on the roof. There's voltage on both sides. Everything's fully energized. And now the firefighter's going to go up there, pull a disconnect, think he turned the system off and didn't do a darn thing. And now he's going to get shocked because he's going about his business thinking everything's off. And the fact is, nothing's off. And so he said, well, wait a minute, guys. Time out. If you're really going to come down on us and say we've got to turn stuff off, we got to do it right. All right, we got to do it in an organized way, and we got to actually do something that has benefit to an emergency responder. So the 2014 code, there was lots of discussion back and forth, and we said, okay, what we're going to do is we're going to shut down to a safe level conductors that leave the array. Okay, particularly conductors that go in the building. That's 2014 code really provided benefit to emergency responders for conductors going in the building, because those are the ones they care about, the ones they can't see. The ones that disappear on them. When they're doing overhaul and they're tearing sheetrock out or tearing ceilings down and stuff like that, that's the stuff that gets them. Okay? So that was the big benefit of the 2014 code. But it was fairly broadly written on purpose to kind of let this, the dust settle on how it was going to get done. The 2017 code said, okay, we got to get a lot more specific about it. And then they said, well, wait a minute. The conductors leaving the array was our main focus, but what about the conductors inside the array? And so there was discussion from day one about, can you actually shut a PV array off? And the answer is, you probably can't shut it completely off, but we can certainly reduce the hazard in the array. And so we have options on how to reduce the hazard in the array, and that's what we're talking about now.
Okay.
Okay, so that's the background. And so in the 2014 code, we were required to shut down conductors more than 10 feet from the array. So that gave us a distance, a little bit of leeway to put disconnecting means and shut down devices and things like that. And a little bit of leeway between sections of an array as well. And so that's one of the big questions. What is the definition of an array? Well, that comes down to the local jurisdiction to make some kind of a call that all that's the array, or, well, this section's all by itself, so that's an array, and this section's all by itself, and that's an array, and so now you got to shut off those things individually. So that's another question. In the 2017 code, we said the array boundary zone is 1 foot from the modules. That's extremely limiting. Okay, now it's really clear that something that's separated from one another, they're two separate sections. They're no longer connected at all. All right, so 1 foot between the modules. So if you had modules that the rows were within 2 feet of each other, 1 foot around each module, then they would be considered part of the array, and we'll see that in the next slide. There are 3 options for reducing the hazard within the array. Now, the stuff within the array has to do with, that requirement does not come into effect until January 1, 2019.
Which one?
Number 3 here.
Okay, this is right here.
3 options.
Okay.
Okay. That's because that's a major change. This was the crux of all the drama of the 2017 code, was adopting requirements for within the array. All right. Tremendous amount of concern and quite right on the part of the solar industry is saying, hey, wow, you're going to require us to essentially try to shut down our array, which is really hard to do. And right now, there's only a few technologies that can actually do it. And so let's talk about how that would even happen if we could even do it. So lots of discussion on that, and that was deferred and only becomes effective January 1, 2019.
January 1, 2019, which is before the 2020 code. Gotcha.
That's before the 2020 code.
Okay.
We deferred it basically as far as we could.
Did you want to go next slide, or you want to
so there's 3 options here, and this is a good summary. You could have a listed rapid shutdown PV array. That has yet to be determined what that even means yet.
Okay.
There is studies going on. There's some research going on. There is no standard for that whatsoever, so there is no such thing as a listed rapid shutdown PV array today. You could curtail the voltage of the conductors in the array zone to 80 volts or less. Okay?
Where's
That's
that 80
option
volt?
2.
We heard about the 80 volts back in the in the ground fault.
Arc
On the arc fault. What's 80 volts?
Arc fault. The reason the number is 80 volts in arc fault, and the reason the number is 80 volts in here, is it's a practical limit of the voltage of a 72 cell, or maybe a 96 cell, actually a 96 cell module.
So you could have a module that could give you 80 volts. Got it. Okay.
There are modules on the market that are over 80 volts, for sure. Most of your thin films are over 80 volts right now, and there are a few crystalline modules that are over 80 volts. But the vast majority of the products on the market today are under 80 volts on a single module level.
Gotcha.
And there are also other systems out there that are designed to run below 80 volts.
Okay.
10K solar would be an example of that. So you're segmenting the array. If it's a high voltage array, like a 1,000 volt array, you're segmenting the array into subsets that are lower than 80 volts, and you're doing that to lower the threshold voltage so that the shock hazard becomes less. It's not zero shock hazard,
right?
But compared to the shock hazard of 1,000 volts, there's no comparison.
Gotcha.
All right. And then lastly is the option of having an array where it's almost impossible to get shocked on it because you have no path. Okay, so you have no grounded metal, you have no exposed wiring, you're 8 feet from any grounded metal, And that's in a situation where you would have to literally peel the system apart and try to interject yourself in the circuit to get shocked. So the probability of getting shocked is extremely low, and it's probably every bit as low as any of these other things. Okay. So that's where those two things come from. 2 and 3 were also meant to provide some input into what a listed array might even look like.
Okay.
Would be a low hazard condition, a low voltage condition.
Okay.
And then lastly, it requires that all equipment that's used for rapid shutdown be certified for rapid shutdown, which is a new requirement compared to the 2014 code. In the 2014 code, it said anything you're using for rapid shutdown has to be listed and identified, meaning there has to be a certified product and you're using it in accordance with its certification, up on a roof or whatever it's certified for. Now, these things have to go to the extra step of being certified for rapid shutdown, and we have a new rapid shutdown standard that's in draft form right now. UL has certified several products in their CRD to this new draft standard. Intertech has listed several products, and the standards technical panel is currently reviewing comments on that particular standard.
So is that to say we don't have a device that meets the requirement yet because we don't have the standard written, so we don't have a component that is written to a non-existent standard? So we have...
No, Ryan, that wouldn't be true. No.
You
Nice
ignorant.
try. Good try.
Jane, you ignorant. No. Sorry. There are two standards being talked about here. The first standard that was mentioned is the listed rapid shutdown PV array. That's the power producing unit. And that is in its very infancy. There is no draft standard for that yet. The rapid shutdown equipment, which is things like switches and contactors and all that kind of stuff, there is a draft standard for that, and there are several products that have been certified. So those are on the market, and 90.4 is not an option for...
To the draft standard. They've been...
That's correct, and that meets the requirements. So you cannot invoke 90.4 on rapid shutdown equipment, which several states have tried to do over the last several years.
Okay.
And I'm not going to name them all, but they're not so intelligent. So let's move on. There's your 1 foot boundary, what it looks like. And so if the array sections are butted up next to each other within 2 feet, then they become part of one. If they're separated, as you see that upper section separated, then you're going to have to be able to shut down those conductors that go between the sections. And also, if you bring your inverter within 1 foot of the modules, then it becomes part of the array. So it basically becomes absorbed into the array footprint.
That's over here.
All right? So those are the basic rules.
Is this one right here? This is a separate one then, huh?
That's a separate one. So with current technology, that's going to be really difficult to do without shutting down the individual modules. Oh, sorry. That's another artist rendition of what a fire might look like on a roof.
Another way to shut down a module.
That's another way to shut down a module, too.
All of them. Yeah, all of them.
Just wait a few hours.
Just wait a few hours.
You want to see that?
No. Okay, so next, did you have a question?
Well, I kind of did. Back, on that one. So bottom right corner, you have 3 modules kind of doing a triangle thing, and you're showing some wiring going from those to the second row. You're showing some wiring there. So if you take that wiring and you keep it within the array boundary, those conductors are not going to be subject to that.
Correct.
So you can have holes within your array, essentially, as long as you keep your conductors within that 1 foot boundary.
That's right. Because what you're doing is you're telling the emergency responders, if you're right up next to PV modules, you're in the array. If you're a little bit away from them, you're not.
So if that third module is gone, that hole is still going to be present, but all you have to do is wire your conductors around that hole, if you will.
Yeah, if this was gone here, then
that pink is still going to be right where you're showing.
Then you'd have it like this here.
Yep.
So, well, actually, it would be, well, the pink would be right there. Yeah, just like that there.
Now, in the real world, these gaps that you see are commonplace, very commonplace. It's extraordinarily difficult to build an array that is monolithic on a rooftop. And so the provisions related to the 1 foot boundary are extremely limiting to installers today, even without the effectiveness of this inside the array boundary on January 1, 2019. So in general, if I'm going to do this on a roof that's got arrays all broken up, I am going to go today to module level control. I'm going to go to module level shutdown because I don't have any other way to easily comply with the basic requirement of shutting down conductors outside the array.
When you
Does
say
that make sense?
module level control, that means individual module control.
Yeah, so we're talking about things like microinverters that we've discussed and
Right.
DC converters. Both those products that are on the market are ways of actually controlling or shutting down essentially to the module level, or to maybe 2 modules or 3
Okay,
modules.
got it.
Okay. Another thing that was not discussed in the 2014 code is the device that actually does the initiation to turn the thing off. Okay. And so this is providing detail on what that initiation device would be. It could be the service disconnect, which means that when the AC power goes off, it automatically shuts down the whole system. It could be the PV system disconnect, which would be the same type of a thing where loss of AC power would shut the whole system down. And then the third, which actually turns out to be a very common method today even, is to have a switch that does not interrupt the AC power necessarily to the system, but it only interrupts it only is an on-off switch for, say, contactors or the like that would initiate the shutdown of the conductors rather than the shutdown of the AC power to the output of the inverter. Okay, so here's an example of this would be a microinverter example, and what I've shown is in green is conductors that would be shut down to 30 volts or less when you turn off the either the main service or the PV system disconnect. Yellow is indicative of something that would be below 80 volts, but possibly above 30 volts.
In 1 second, that's because I would be having microinverters.
Correct.
Right?
And so now
That's
this,
why I have 80 volts here, because each individual module would not be over 80 volts.
Correct.
Because you taught me that has to do with the size of the modules.
Correct.
So therefore 80. Now, is this any voltage here on the green at all?
actually no.
Okay.
It's 0 volts,
That's
but
what
it's
I thought.
compliant.
Okay, gotcha.
Green means safe.
Gotcha.
We don't like to use the word safe because
Yep.
all the lawyers line up down the road when we
Gotcha.
start talking about safe.
Gotcha.
We talk about lower hazards.
Okay.
And then there's a little informational note that said, why in the world would you have a little switch? Why wouldn't you just use the main service disconnect? Well, if you had a battery backup system, you've got to have a switch, because if you shut your whole system down when the power goes out, I think you just threw out the whole reason for a battery. Okay? The normal condition of an outage is you want to keep running with the battery system and everything stays up, because that's why you paid all that money for it. But in the very special case that there's an emergency and somebody wants to shut down the voltage on the system, then you operate this switch, and that does that independently of the utility outage. Okay. A readily accessible switch, here's an example of a 600 volt array on a house, for instance, where you have a contactor of some type up on the roof. There may be another contactor at the inverter, or it could be some other device at the inverter. It could be a resistor up in the array, all kinds of things that could be done. This is a battery-based system. In the 2014 code, this is a very important distinction. In the 2014 code, rapid shutdown only relates to a PV system. One of the really big important issues with the definition of a PV system is that with a PV system, the 2014 code included the battery system, the backup system, all those other systems were part of the 2014 code. In the 2017 code, the PV system in a battery-based system ends at the point at which we start to interject other types of systems like energy storage and the like. So that's a really important distinction. It simplifies rapid shutdown in one way for the 2017 code, because it doesn't require you to mess with all the other circuits related to battery storage. Now, that doesn't mean that it's not a good idea to think about those other circuits and how an emergency responder would shut them down, but you would apply other parts of the code. We have Article 702 on optional standby systems that requires a placard at the service entrance to show how to shut down an optional standby system. So your backup circuits and things like that would have a placard for that. In that case, you'd only have to shut down that one circuit. Multiple PV systems. So if you had multiple PV systems on a single circuit, you either have to group
single service.
Single service. You have to group those rapid shutdown switches to one location. You do not have to deal with PV systems that are connected to other services on the same building. Okay, that's a very important thing. We're not going to require that you go to one place and the fire department, for instance, could shut everything off on the building in one place, because that's not the way we do things normally. If you've got multiple services, you got multiple services. And if the utility really wants to shut down all the utilities to a building where there's multiple services, they've got to go to all the individual services and shut them off. They don't have a choice on that matter, and they understand that.
The code allows me in 230.2 to have more than one service to a building under conditions.
Correct.
And I might have 2 or 3 services to a building because, let's say, the size of the building.
Large.
And you're saying, well, we're going to put the disconnecting means for the PV system in one of those locations, and the utility would be going to all 4 service equipment locations, and they'll be turning on all of, and while they're doing, they're going to find the PV system.
Right. If all the PV is connected to one of the services, that's great.
Right.
But if it's connected to all 4 of them, if there's systems connected to all 4 of them, we're not required to operate all 4 of those at the same time from one device. That's not the case at all. Okay, we're just saying that the stuff that comes into that service gets controlled at that service.
Ah, gotcha. And the disconnect. Okay.
All right. And then we get into equipment. And this is where, when we say, oh, everything's got to be rapid shutdown certified. Are you going to certify a main service disconnect for rapid shutdown? Absolutely not. That's silly. Okay. So switches, initiation devices that include service disconnects and normal switches and control switches and stuff like that, that are just on-off devices, do not require this rapid shutdown capability to them. However, anything else would have to be listed and labeled for rapid shutdown.
What's that informational note? Inverter input circuit conductors can remain energized up to 5 minutes with inverters not listed for rapid shutdown.
That's just some nice information that says that some inverters out there have a lot of internal capacitance to them. And so if you shut off the array side and open the circuit on the array side, the inverter side may stay energized for a while. Now that's becoming less and less. There's very few inverters on buildings that have much internal capacitance. And so especially when we went to the 30-second requirement, which was a difference between the 2014 and the 2017 code, went from 10 seconds for the 30 volts to 30 seconds. A lot of our devices that are DC to DC converter inputs can actually comply with that 30 volts. And so part of the testing and listing of an inverter is to verify that the input voltages are below 30 volts on the DC side, and the output voltages are below 30 volts on the AC side. So that's how an inverter would get certified as a rapid shutdown piece of equipment.
Okay.
Now we're jumping to 69056, and you've got a couple slides on this, but this is just to bring this up now, and we can kind of reiterate it later. The signage on this is as important, equally as important as the safeties, because it's providing information about what's going on in this building. So when you're reducing the hazard within the array, this yellow sign is a required sign. And that basically says that you shut down conductors that leave the array. And then within the array, there's still a caution there, but there is a reduced hazard. Okay, things like microinverters. So if somebody was installing a system today that met the requirements that are required in 2019, today, they would use this sign. All right. After 2019, everyone's required to use this sign, and everyone's required to comply. Does that make sense?
Yep.
The next sign would be a minimum requirement of today. Okay, and it would be a good idea to use for 2014 compliance as well, because you're shutting down the conductors that leave the array. It's also saying that within the array that your wiring still is hazardous.
So what this is trying to say is that, what is the yellow supposed to, what is it?
Caution.
Is this telling me that this is safe inside the array?
No, it says caution.
This is caution.
Yellow is caution.
We'll make a note in our text. that this is caution that what? The
Reduce hazard. There's a reduced shock hazard in the array. Doesn't mean there's no shock
But
hazard.
that could be up to 80 volts.
Could be up to 80 volts.
Okay. This one here is danger.
Could be
meaning
up to 600 volts on a house. Could be up to 1,000 volts
inside the array.
inside the array.
Okay, so this is a hazard. This is could be up to
1,000 volts on
up to
a
the
building.
voltage of the system. This would be limited to 80 volts. Okay,
Or
that's it.
some other reduced hazard.
Or whatever. Okay, reduce hazard. Gotcha.
And then comes the problem of what about you install a system today under the 2017 code or the 2014 code, and then 3 years from now they adopt the 2017 code and you're having to do reduce hazard within the array. That's a complicating factor because now you got two different systems up on the roof, and you would have to somehow show what's what on the roof. Okay.
So this is the 2014. You have your whatever
Yeah.
your system voltage here. This over here is going to be a caution because it's bringing it down to a safe value, not exceeding 80 volts.
Right. So you have a dotted line around the stuff that remains energized, and don't around the rest. So this is convoluted. This actually happens quite a bit, by the way. And, you know, when I do trainings, I ask how many people have added PV to a building, and the
Yeah, I
answer
can
is
see
about
that.
half the class easily is added PV to a building, and so it's very common for this to occur. It is more complicated, and so one of the different jurisdictions have actually treated this differently, and talking with some of the jurisdictions that I've worked with, some jurisdictions have elected to say, you know what, if the building already has a PV system on it and you're adding to it, we're not going to require that the new system meet the requirements of rapid shutdown, particularly and only because of the potential for confusion for the firefighter. We don't want the firefighter to be confused. Which end of the building was that? I can't remember. Which safe? Well, we don't want to do that. Okay, that's their local jurisdictional decision. But the code says that if you have two different types of systems, you have to come up with a sign that shows where it stays live. And then lastly, the rapid shutdown switch has to be identified. That's new in the 2017 code. There's nothing in the 2014 code that
Right.
tells you what to do, and this is what has to be on the rapid shutdown switch. And then this talks about how would you comply with 690.12b2, which is the reduced hazard within the array that will become effective in January 1, 2019. And you could put a string inverter at the edge of the array with DC converters or shut-off switching devices at each module. That would be one way to do it. You could move that string inverter to some other location as long as the voltage from the inverter didn't imply anything back to the array. You could use microinverters that segment to each module. Either you could have 1 to 4 modules on a microinverter. If they have independent plug-ins to that inverter, that would be one way to do it. Or you could have a building integrated array with no exposed metal or wiring and installed more than 8 feet from ground to metal. So these are currently available options and products, and we're certainly looking forward to many more options in the future as this starts to mature.
Well, and then there's also third-party options, correct? Of meeting you have string inverter located at the edge of the array. We also have options of contactors with remote switches, things like that could be installed from third-party options.
Correct.
Rebecca actually sent me, Bruce, if you want to pull this up on the screen, sent me a really nice little diagram from, is this from SMA?
Yeah, and I'd like to talk about it because they designed that to meet 2014 requirements. And so I'm a little bogged down trying to think about if this will meet 2017 requirements or if it's not quite right. If it's not quite right because of the listing they have or don't have, or...
Yeah. That last slide was about B2.
Right.
This is B1.
B1.
Okay.
Okay, so this particular product would be allowed to be installed under the 2017 code up to January 1, 2019. All right? Because it's rapid shutdown certified, so it's certified equipment. They've got the products listed, so it meets all the requirements of 2017 code. But once 2019 hits, this product in that form will not be acceptable anymore. They're going to have to go to their new subsidiary, Tygo, and put Tygo DC converters on the modules.
Okay.
That would be one way to do it.
So I also, when I look at this, I feel like a lot of these devices are very focused on the DC circuits. And this one you put on the roof and it can open the DC circuits on the roof. Does it also turn off the inverter? Or does it disconnect the inverter output circuits to the point of interconnection? That's
Yes. So the SMA device, which is what we're dealing with here, has a separate push button or switch. It's a little separate switch. And the reason they have a separate switch, they could have activated all this stuff with the loss of AC, but they have a
Right.
secure power supply.
They
that
what?
thing up on the right. The thing on the right, secure power supply. That wants to stay on in all cases unless you push the button. Okay, when you push the button, that disables the secure power supply as well as the AC output. So the AC side's covered and the DC side's covered. And that's why they
What is
elected
that
to
secure
do it.
power supply? Is that DC that we don't see down there?
No.
That's that little thing we were talking about yesterday.
It's an outlet.
Oh, that's that receptacle.
The
Oh,
receptacle,
yeah,
the
yeah,
little
yeah,
special
yeah.
rep.
1800 watts. It's not little. It's 1800 watts.
Well, okay, a circuit, 20 amp circuit.
Yeah.
It's a standard size.
I know.
Okay, Tom?
Quick question.
We're diminutive people.
You said earlier that if you come within 1 foot of those panels, you're within the array, and which could be
The
The array
amount.
boundary.
the boundary. So, like in that picture right there, how could you not? I mean, if you're walking up through that array, you're within a foot of all of those panels.
Okay, what's your point?
What does rapid shutdown get you?
Okay, so up to between now and 2019, we're only required to shut the conductors off that leave the array.
That leave the array boundary.
So if
Or
it's
leave the
1 foot
array
away.
boundary. So
Right.
if you're kicking the edge of that, it could still be up to 600 volts.
Right.
Okay, but if you're a foot away from it, it's going to be pretty much zero. It's going to be below 30 volts. Okay, so and another very important point here is that if you touch an unbroken module, you're not going to get shocked because we have a safety standard for that. Okay. Really, the only issues that a firefighter has to work with or an emergency responder has to work with is really damaged equipment. That's what we're really talking about. Because damaged equipment is the only time you're ever going to be exposed to anything live. Because there's no such thing as live conductors in a PV system that are just hanging out there that anybody can walk up to. So an unbroken array that's grounded metal and everything like that, I don't tell people to touch it, but it's considered safe according to the National Electrical Code and how we do things. Just like we can touch lots of things that are metal in this building today, even though we have electricity in this building. So this issue is, okay, now you've got damage to equipment. What's going to happen? Well, okay, inside the array, that's a bit of a conundrum, and is why we're doing all this research stuff. We know that we can reduce voltages and stuff like that, but there's a lot of questions to answer in there. In this particular case, we push a button, and that shuts the conductors off that leave the array. Particularly if these conductors dive into the building, we don't know where they went. As a firefighter,
Right.
I have no idea, if I were a firefighter, where that thing went in the building, what route it took, or anything like that. And so if I'm doing an overhaul after a fire in this building, I want to make sure those things have been turned off.
Yeah. So I've always, with my perspective of a PV on a roof for first responders, you have the conductors that go in the structure, which they have to worry about because they're energized all the time. And B, if I have to ventilate the roof, they're going to be on the roof in and around the array. So the first responders, I would guess, or are aware that they should not be within 1 foot of a panel on a roof when they're on that roof. Even if there's a rapid shutdown, they should stay outside of 1 foot from any PV array. Would that be accurate?
They should try to avoid those areas if possible.
Right.
In a firefight, not all things are possible. Okay, we have fire setback rules for access pathways, and we're required a 3-foot access pathway from eave to ridge, at least on one side of a roof, and we have to have 2 of those now in the new code. Okay, one of them has to be on the street side.
What code is this?
This is the fire code.
Right.
Okay, so the fire code has access rules, and this particular example doesn't match the fire code rules.
Yeah.
Okay, because that's not an adequate access pathway up the middle of that.
That's what.
All right. Normally it would require 18 inches on either side of that valley. And in that case, it's unlikely they'd come in contact with it.
I agree. I agree. I guess that's what threw me about. That's probably marketing 101, right?
Yeah.
And
Put the right
never
thing in
trust
there.
the marketing literature.
Okay.
Well,
We're
this
done
is
with
a
the
good.
wrap-down?
This is a good example of the array definition. If that true fire code pathway was there, we would really have two arrays that you're going to be trying to control in this picture, because they would be more than a foot apart.
Or two.
As it stands now, maybe not, but
That's right.
the intention, I would say the intention of the code and the intention of what should be done here is one on each one of those roof surfaces.
It shows you the importance of how fire codes, electrical codes, structural codes all work together in a system, because you may follow the code in one area, but you may violate something in another area, and they all work together from a safety perspective.
Richard?
I have a question for Bill. There was a TIA that was put out in July last year, changing the 10-second rapid shutdown requirement to 30 seconds. And the rationale had to deal with utilities and rolling brownouts, and the notion that the utility actually wanted the PV systems to stay primed and ready to go and not disrupt the grid so abruptly should it go down. How does the rapid shutdown extending out to 30 seconds, when coupled with the UL 1741 standard that requires that the inverter disconnect, how do those things kind of work together? Is it because the rapid shutdown hasn't fully taken place that the inverter can come back online faster, or
Right, yeah, so basically the idea and the reason it was extended was to allow plenty of extra time for the inverter to do its job for grid support. Okay, so now we have all these new regulations for, it used to be that an inverter was considered a hazard to the utility and get out of our way if we're having problems. We want you off, we want you to go away so we can fix our problems and come back. And then after we fix all our problems, we're going to come back online. Well, once you get a lot of PV on the system, you don't want PV to go away. You want to say hang in there as long as you can, because if we lose you all at once, you just crashed our entire system. Okay, so now we have all these grid support requirements to say hang in there, hang in there, hang in there. And part of it might be, okay, stop inverting for just a couple of seconds and let's see what's going on, and then come back. So don't go away, don't turn off, don't shut down. We want you to come back. We're just saying stop for a second. And so all those new regulations come into play and complicate what an inverter has to do. You're telling me to run, you're telling me not to run, who's telling me to run, I don't know what's going on. And then some firefighter comes on and says, shut down. And you're like, well, but the utility's telling me to do that and I can't. Well, okay, I'll shut down. And so, the firefighters say, hey, 10 seconds, 30 seconds, it doesn't matter. 5-10 minutes, yeah, that matters. Okay, so nothing happens on a fire scene in 10 seconds. All right, so you operate the switch. It's going to be 30 seconds. You don't have to sit there and count. You're not going to be able to run over to the ladder and get on the roof before this thing is down to 30, down to 30 volts. So,
Okay. We're done with that?
that's enough of that.
That was a great job, though. I think
all I have to
everybody
say
really
about that.
appreciates that. All right.
That was Jason's diagram, by the way. We have to give
Okay.
some credit to Jason for the pretty pink diagram with the array boundaries. Jason Fisher.
And he's with?
He's with Solar City now.
Okay.
And he was supposed to be with us, but got sick.
I know. What a bummer.